All right, guys, so we're going to talk about increasing and decreasing intervals and behavior. We're going to do that at the same time. So let's just go ahead and start with this function that I have here to keep it simple so we can kind of explain what's going on. So when we want to talk about intervals where the function is increasing and decreasing, what we're talking about is looking at the function over the entire domain from negative infinity to infinity. So basically what I always tell my students is basically put your finger on the graph that you can see and follow it all the way from negative infinity to infinity. So now the graph only starts over here where it's highlighted, but as I go in this way all the way to the left, what is the function doing? I am increasing. Now still over here, it looks like I'm constant, but it's not. It's just increasing slowly, then it picks back up and increases. So as I go from negative infinity to infinity, this function is increasing throughout. It is never decreasing. This function is always increasing. So what we have is it's increasing from negative infinity to infinity. We always describe the intervals for increasing and decreasing using the domain, the x values. And then this is decreasing, like we already said, never. It's always increasing. Now let's talk about end behavior. Let me get rid of these arrows because I don't want to confuse you. I'm going to leave the negative infinity and the positive infinity. This is also negative infinity on the y and positive infinity up here. That actually didn't come out too well. So what we're talking about with end behavior is as we go to the left, what is this function doing? Now notice I'm not starting all the way on the left like I did before. I started over here and I worked my way up to the function, to going this way. We're not doing that. We're basically starting anywhere, you can say, just say in the middle. And I'm following this function. I'm going to use a different highlight color here to illustrate it. So what am I doing? Where is this function going as I go to the left? Where is this function going? Well, it's pretty clear that this function is going down to negative infinity. So as we go to the left, the function is going down. Now let's look at the right. As I go to the right, I'll pick a different color. What's the function doing? It's pretty clear that that's going up. So as I go to the right, the function is going up. Well, we use a specific notation for that. So the end behavior. So what we're saying is f of x, that is your function. The function is going, let's just pick this one here, is going down. So that is negative infinity. It's going down. We represent it as negative infinity. The words here that are highlighted don't typically go. I'm just using it to help you write the end behavior. As x, the domain, goes to negative infinity. Let me move this over a little bit so I don't get mixed up in the graph. So the function is going down as we go to the left. So we go down and as it's going to the left. So f of x is approaching negative infinity as x is approaching negative infinity. Function's going down as we go to the left. Let's do the other side. So the function is going up, which of course is positive infinity, as x goes to the right, approaches positive infinity, which is the right. So again, typically the words are not written here. I'm just using it to help you define the end behavior. So the function is going to negative infinity, which is down, as we go to the left, which is negative infinity. Then the function is going to positive infinity as we go to the right. So it's going up as we go to the right. So let's take a look at another one. So let's talk about increasing and decreasing with this one. So if we start, remember, for increasing and decreasing, we have negative infinity all the way to infinity. We start, don't confuse intervals with end behavior. So if we want to figure out where it's increase and decrease, when you start from the very far left point of the graph and follow it, what am I doing? I'm increasing from here to here. Then what happens? Then I am decreasing from here to here, and then I am increasing from here to here. So I have 2 increasing intervals and 1 decreasing. Remember, we use the x values to describe that. So this is increasing from negative infinity to negative 1. That's the first one here. And then from 1 all the way to positive infinity. Again, we're using the x, the domain values, to describe that. We're using the x values. Then this is decreasing, and I can even use the colors. That's the increasing part. So we are decreasing from negative 1 to positive 1. And I can use the color I used for that too. I think it was this one. Close enough. Okay? So let's talk about the end behavior then. So for the end behavior, remember that we want to see what the function's doing as we go all the way to the left. Is it going up or is it going down? And then what's going on as we go all the way to the right? Is it going up? Is the function going up or is it going down? So f of x is approaching over here. You can see this is going down to negative infinity. This is going up to positive infinity. So the function is approaching negative infinity as the domain is going to the left, which is negative infinity. And then f of x is approaching positive infinity as the domain goes to the right, which is positive infinity. So if I use a different color here, you can see that this, I'll just do this part, matches that right there. And then just pick this color. I want to be in the same purple, sorry. From negative infinity down as we go to the left. All right, so let's look at another problem here. So again, we're going to start with increasing, decreasing. So let me put I'll put my negative infinity over here. I'm going to put my finger or pointer right on the left point of the graph and follow it. What am I doing? I'm going down. I'm decreasing. And then I increase, and then I decrease again from here to here. So now I have 2 decreasing intervals, and then I have 1 increasing interval here. So we are decreasing from negative infinity to 0. Remember, don't get confused. I know that all the way up here is infinity, but that's not how we're describing the intervals. We are going down as we go in from negative infinity all the way to the right. Remember, we start at the far left point and going in. We're using the x values. And it's decreasing from 2 to positive infinity. As we go from here all the way to the right, the function is going down, decreasing. And then we are increasing from 0 all the way to 2, right, from here to here. Okay, so let's talk about end behavior. Let's talk about end behavior. So I'm going to get rid of a couple of these lines, not to confuse you. I'll leave the highlighting no. So for end behavior, the function, remember, as we go to the left, are we going up or are we going down? As we go to the right, are we going up or are we going down? So it's pretty clear that as we go to the left, the function is going up. And then as we go to the right, the function is going down. You can just follow the arrows there, you can see that. So f of x is approaching positive infinity as x, the domain, goes to the left, which is negative infinity. Then f of x is approaching negative infinity as x approaches positive infinity, as we go to the right on the domain. All right, making some progress. Let's look at a different function than what we had before. So this is, just so you know what the function is, because you're going to have to graph these really to get a good picture. So this is square root of x squared minus 4. Sorry, it's a minus 4. Just so you know. All right, so let's talk about increasing and decreasing. Again, this is negative infinity, and this is positive infinity. So as we go, starting from the left, and we follow this down, what am I doing? I'm going all the way down. And then once I get to here and go to right, what am I doing? I'm increasing. So I have one increasing and one decreasing. So we are decreasing from negative infinity all the way to negative 2. That's this point right here, negative 2. And then we are increasing from this point here, which is 2, to positive infinity. Now let's talk about end behavior. I think hopefully we're getting this. So as we go to the left, the function's going up, and as we go to the right, the function is going up. So f of x approaches positive infinity as x goes to negative infinity to the left, and then f of x goes to positive infinity as x goes to the right. So that is the end behavior. Let's try to get one more in here. So this is definitely a unique function here. It's a rational function, and this is 1 over x plus 1 minus 2. So what you're going to notice here is we have a vertical asymptote here, which is at negative 1, and then we have a horizontal asymptote here, which is at negative 2. Y equals negative 2. So we got a VA here at x equals negative 1, and we have a horizontal asymptote here, y is equal to negative 2. Well, how is that going to affect the increasing and decreasing? Remember, this is negative infinity, that's positive infinity. So as we come in from the left, I already have the highlight, but I'll pick a different color. We start here and we go in, what are we doing? This is decreasing. Then it goes and approaches the vertical asymptote. Then what? It jumps here, and then I'm still decreasing. So even though it's jumping back up here, it's only because of the vertical asymptote. It actually doesn't increase from here to here because that's an undefined point. So it is only, this function is only decreasing. It is, increasing is never. So increasing, never, and it is decreasing from negative infinity to negative 1, the vertical asymptote, and then from negative 1 to infinity, the other side of the asymptote, all the way to the right. Let's talk about end behavior. So think about this. We have this horizontal asymptote here at negative 2. So as I go to the left, this function is approaching that vertical asymptote. So for the end behavior, f of x is approaching negative 2. It's approaching this horizontal asymptote as x goes to the left, which is negative infinity. And of course, as you go to the right, it's doing the same thing. It's approaching the horizontal asymptote. So f of x approaches negative 2 as x approaches positive infinity. All right, see you in the next video.